Um, Hello, everyone. My name is Marcus Extavour. Welcome. This is a Zoom about XPRIZE carbon removal. Hello, everybody. It's great to see you. Thanks for following on with us. And this session is part of our team summit this week, specifically the rocks track. That means anyone doing anything to do with mineralization.
Recording in progress.
Great, we're recording. This is for you. A brief run through of the agenda. We've burned up at 15 minutes, but don't worry, we'll be all good. We've got three fantastic speakers who are from the space to share some insights on, tips and tricks, or how they see the space, or just, general thoughts on mineralization and CO2 removal. So I'm going to hand to Phil Renforth in a minute, but I just want to mention and introduce Phil Renforth is here from Heriot-Watt University. He's also one of our XPRIZE judges. Don't email him all your judging questions, but he will be one of the people looking at your proposals. Any questions you have can come to XPRIZE staff. Second person you'll hear from is Colin McCormick, who is at Carbon Direct. Colin has been a great friend to XPRIZE for a while. He's given us a lot of input on shaping this prize design, and he knows the mineralization space very well. And last but not least, you heard Marianne's voice in a moment, or a moment earlier. Marianne Tikkanen is here, one of the co-founders of Puro.earth. We're thrilled to have each of these folks. They're each going to speak for about 10 minutes, share their thoughts. So our order of speakers is going to be Phil, Colin, then Marianne. Next thing we'll do is just open it up to questions from anyone here. You can ask questions of those folks while they're here, because we won't have them all day. You can also ask questions more generally about the competition. Myself and XPRIZE colleagues will be here for that too. And then the last sort of half, or probably 45 minutes of this meeting, will be individual breakouts, so that you have a chance to meet one another. You can talk about collaboration, you can ask each other questions, you can share it, exchange info, you can do it whatever you want. We will just rotate breakout rooms probably every 15 minutes for the back half of the hour, and that takes us to 2 hours. So without further ado, let me say thanks again to our speakers for coming. Phil, I'm gonna go over to you. If you've got slides, feel free to take over and share the screen, but over to you, Phil.
Great, thanks, Marcus. Yeah, I'll share my screen if that's okay. I'm delighted to come and present, actually, and it's marvelous to see so many people interested in the rocks space. I mean, it's not been like that for a while, so it's great to see the interest. Okay, and I should go into presenter mode. There we are. Hopefully you can see my slides. It's not coming up in a funny way.
No, that looks perfect, Phil.
Fantastic. Okay, so these are, I suppose, hopefully there's some coherence to this. I've sort of put these together as a sort of collection of thoughts and reflections on, I suppose, doing this for a little while with a bunch of different programs and projects. These are just a sort of collection of thoughts from that experience. So hopefully there's some sort of coherence in that. And I suppose my comments might sort of focus more on scale rather than cost, because I know that the XPRIZE are going to put out quite a detailed description of how costs are presented. And I think that might answer some of the usual questions that I have. So, but my comments are going to be more sort of around scale. I'll just keep an eye on the time as well. So, I think the first question that we often ask of these types of projects is, can both the inputs and the outputs scale to gigatons? So the idea that we're sort of attacking here is that we want a removal technology that can scale to sort of gigaton scale. And I think that's the question that we have to pose at these technologies. So, often we see folks thinking about, their inputs and, do they scale, but not their outputs. So, if you're producing a gigaton worth of CO2 removal, and you're also producing a gigaton worth of waste solids or waste waters or waste gases, then where do they go? We have to account for those within this process, because if you're operating at a gigaton scale, there's no rug under the carpet in the planet. So, we're talking about nowhere to hide that type of material. So you need to make allowances for what you plan to do with that waste. And I would, as a sort of basis, urge projects to at least start from the perspective that what they're producing is a waste, and then argue that if you think it's a byproduct, as in you think there's an onward market for for the things that your process produces, then argue from that position rather than assuming that you've got a byproduct that you can sell. And I suppose I'll come back to that in a second, but I suppose the other common pitfall is that there's no free alkalinity. I've seen processes that, or projects that sort of have an input for a really caustic input, like a sodium hydroxide solution or a potassium hydroxide solution. And then, through the magic of their process, they form a carbonate mineral with the CO2 locked up in it. But I suppose if you're starting from sodium hydroxide or potassium hydroxide, you really need to say where that's coming from. So you don't get free alkalinity in this world. If you did, I don't think we'd have a CO2 problem, at least one that was scalable. So probably the exception of that is waste, but only to put the caveat that if you start using wastes to remove CO2 from the atmosphere, then it probably will stop becoming a waste very quickly and start becoming a byproduct. So there'll be some sort of value attached to it. And that's maybe just something to keep in mind if you have a process using wastes. Apologies for those that have already got sort of a geological background, but I think this is an important distinction to make in that rocks and minerals aren't the same thing. And I think sometimes it's often used interchangeably. And not because I want to be sort of nitpicky or pedantic, but there is a sort of functional reason why we should make the distinction. I should say, for those that don't have a geological background, a rock is composed of many minerals, and a mineral is usually just a chemical formula. So the reason why it's important to make the distinction is that if you're looking to scale this process, you almost certainly will be using a rock. I mean, you probably won't be able to scale a pure mineral. For instance, you might sort of base your process on phosphorite, which is, hopefully you can see my, you might sort of design it on,
excuse me, Phil. We're having some background noise. I'm not sure who it is, but if you're listening and you're not Phil, please mute. Thanks.
Thanks. So yeah, you might get you might design your process on phosphorite, which is a pure mineral, but actually that doesn't exist so much in nature. It's the sort of scale that I think would be required. So you'd almost certainly be using a rock, which has obviously got phosphorite in it with a bunch of other minerals, which would then dilute that potential. So you'd see that rocks actually have a lower carbon capture potential than pure minerals. So I suppose if you're using I'm happy to be convinced, if you make good reasons for it. But yeah, I suppose if you do insist on using a pure mineral for your process, I think you have to make a decent statement about where you expect that mineral to come from. Okay. Next slide. There you go. So yeah, this maybe just going back to the sort of do your products and waste, do your raw materials and wastes scale? And maybe this is something to sort of keep in mind is, if you're producing a waste material, and you need to say where it's going, and you need to say that within the context of what we already do as a species. So I've popped up on the slide there a table of things we do as a species in terms of mass movement. So the largest thing we do is obviously water, but then there's sort of construction aggregate, so creating rock, crushed rock. Carbon dioxide emissions are in there. Fossil fuels, the human appropriation of net primary production, which is essentially food, mine tailings production and waste from mines, cement production, steel production. the point really is that, if your process has, a waste stream that will be orders of magnitude or potentially much larger than what we already do as a species, then I think that needs a little bit more consideration and argument and discussion within your application. For instance, you might create an electrochemical process that produces chlorine. But if you've got a mass parity between, let's say, the CO2 that you remove and the chlorine that you produce, and you scale to gigaton scale, well, that's, a gigaton worth of chlorine per year, let's say. Well, actually, at the moment as a species, we do sort of on the order of about 50 million tons of chlorine productions. So you need to say where that chlorine's going if you want to be convincing in your process. So things to look out for are mass ratios. So, if you use like 1,000 cubic meters per ton of CO2, 1,000 cubic meters of water per ton of CO2, then you start to really perturb what we currently do as a species in terms of water use. So I think you'll need to reason for a lot harder for where your water is coming from. And then another thing to look out for is, mass parity between your carbon and other products or reactants within your system without a complete recycle rate. So for instance, if your process uses nitrogen and carbon at a sort of similar sort of mass parity, and you're not recycling all of that nitrogen, let's say less than 99% of it, then you'll end up really perturbing what we do is what our impact is on the natural nitrogen cycle. So, I think it's worth thinking about this within the context of what we do as a species and what our current sort of impact on the environment is. And I know I'm running out of time, so maybe I'll just do one more slide, I think. And this is something that I've seen in a bunch of projects previously, and it's a sort of what you might call a bait and switch in CDR. It's where a process is designed for a specific raw material. For instance, it might be a waste stream. And then the reasoning or the logic that a project applies is that process can then be applied to a much larger collection of materials, a different waste streams. So, for instance, you might have a process that reacts CO2 with ash, for instance, from flue gases, combustion ashes. And then you make the assumption that can then apply to waste streams like slag or cement and demolition waste. Well, I don't think that's actually, the geochemistry of those materials are different. So I think that doesn't necessarily apply. And so I think if you do design your process for a material in mind that isn't necessarily scalable, you need to make good arguments to why that can then be applied to other materials that are scalable. Sorry, I probably ran over my time, so I'll just stop there and maybe we'll follow that up with questions later. Thanks.
That was great. Thank you so much, Phil. I saw at least one comment saying, wow, what an amazing table. And there was a request for sharing slides. Mike's just noting the recording of this entire session will definitely be made available. So definitely through that method, if not another. Let's go to Colin then, and then Marianne. Colin, take it away. Thank you.
Hi, everybody. I don't have any slides, so I will just jump through. You'll have to look at me. So Phil, as always, is brilliant and has covered all the important stuff. I'll just try to bat a little cleanup here. Let's start with energy. So the reason we care about mineralization, of course, is it's exothermic, those reactions. And a priori, that makes you think, great, your energy budget is very small. And that would be a bit of a trap. So the trade-off for the fast geochemical reactions in mineralization is that they're slow. And excuse me, for the exothermic reactions is that they're slow. And so usually to design a practical process, we have to accelerate them. That can involve grinding to improve surface area or a bunch of other kind of tricks. And those can rapidly blow up your energy budget. So in addition to kind of the mass balances that Phil really highlighted, it's going to be important to think very, very careful about your net energy consumption. I've seen strategies that then say, great, I'll use renewable energy, zero carbon emissions from that. And of course, that's a deep trap to fall into because the alternative use of that renewable energy to displace fossil might have a much larger net climate benefit than going through a complicated mineralization scheme. And B, that's a hell of a lot of renewable energy to put demand on. So this is probably obvious, but think very, very carefully about those process intensification and their energy demands. Next thing would be to go to MRV monitoring. So, generally these rock strategies are going to produce either solid carbonates or dissolved bicarbonate ions. In the case of the latter, dissolved bicarbonate ions, we get a kind of a 2-for-1 bang for the buck. And so those are very appealing, but the MRV on that is often much harder. So it's almost always easier to measure inputs into the system rather than directly measure carbon drawdown that results from the system, unless you happen to have solid carbonates as the product that you can literally weigh. And particularly in ocean-based settings or anything with water, that bicarbonate measurement process is a deep challenge. So happy to talk about that. I don't want to belabor that here, but this is critical to think about. Monitoring carbonates in soils is also challenging. This is more of a kind of a soil science sampling issue. It can be handled, but I have in the theme of traps, I've certainly seen people imagine that they could rely purely on, say, remote sensing to try to detect that, and just that's not true. Soil sample measurements and very, very thoughtful calibration of those kinds of remote sensing or broad scale sensing approaches are absolutely critical here. Let me jump over a couple of things that Phil covered. Utilization, a lot of concepts in utilization, concrete and cement, very, very interesting here, but it's very important to think about the source of the CO2 that's being used in those utilization concepts. It's easy to imagine, great, I can react CO2 and form mineral products that have economic value. If that CO2 is coming from a point source capture that's fossil derived, you're really talking about an emissions reduction rather than carbon removal. So there's, I know there's lots of careful LCA thinking that's going into this, but it's very important to be aware of that, of drawing a bright line where that source of CO2 is. I had some thoughts on mineral supply, but I think Phil covered them. No free alkalinity, that's absolutely true. Lots of industrial wastes to potentially be used, but many, many of them come with drawbacks. Extracting legacy industrial wastes can often mean disturbing natural settings. They can be within protected areas. They can be near settled areas. Trying to literally extract them at gigaton scale will have consequences. I'd like to highlight that particularly for environmental justice concerns. If you want to go digging up or disturbing industrial waste that's near settled areas, you often can be running into real potential impacts on disadvantaged communities. That applies also for air quality. So mine tailings, other things that you might like to use as a feedstock by further exposing them to air. That can be a very successful strategy, but those need to be handled very carefully such that you don't create downstream air quality impacts for some of those tailings or other materials entering into the air and affecting downwind communities. Let's see. So I want to hop forward, trying to save some time here. Hop forward. Land use and regulatory concerns are also key. I'll speak only to the US context. I'm afraid I don't know the European context very well. Anytime you want to use the surface for instance, enhanced weathering, or you want to broadcast crushed basalt, you definitely need landholder permission. There can be regulatory requirements, but in particular, it's important to think about who owns that land and how onerous it is to get their permission. Farmer by farmer is a real tough thing to do to scale to gigaton. So being thoughtful about how you're going to get that kind of permission is key. When it comes to injection, so anything in situ, in the US, there is still some confusion about what kind of well permit is required. Conventional CO2 storage requires a Class 6 well permit from the EPA. Only 2 of those have ever been issued. They took years to do. My understanding is that injecting CO2 for mineralization, a la Carbfix or some other sorts of concepts, is still a bit of a murky area. Not clear whether a full Class 6 permit is required or class 5 or others could be used in that case. So being thoughtful about any sorts of injection you would want to do for disposal of either CO2 or this could also apply to groundwater needs to be thought through carefully. There's a lot more to say on that, but I'll leave that for questions. And in this same regulatory theme, it's probably worth mentioning in the US legal context, there's a separation between surface rights and mineral rights. So owners of the surface don't necessarily fully control subsurface activities. That varies state by state. So thinking very carefully about who really owns the right to do anything with the subsurface and the context of the state that you're in is going to be very important. So I would urge you to overlay that with your locational thinking and also your sort of future scale up thinking of what's feasible to get to full scale. Okay, I blasted through that. I'm going to try to get us a couple minutes back. Why don't I shut up there and we can move on and we can take maybe a couple more minutes of questions at the end.
Okay, I guess it is me. This is Marianne Tikkanen from Puro Earth, and thank you for having me here. Marcius said that we are from the space. We actually do work globally, but not from the space. Our headquarters is in Finland, but we work in all regions. I took a little bit other approach, thinking of what we have been doing in Puro until now, which is a joint due diligence on behalf of the buyers so that they could trust that every removal ton that they receive is 1 ton removed net. And I'll skip this. I want to show one thing here. So we started 2018 with an aha moment that this is a missing thing and somebody needs to build it. But there was another aha moment today, 3 years after talking about this in every forum. The EU Commission came out with a very promising vision that by 2050, every single ton emitted will have to be neutralized by a ton removed. And this kind of very strong signal that this is going to be compliance market gives hope and faith to the investors for the next decades that this market will actually be there and money can be invested in this market. So that was a paper that came out today. We had a big step up this summer when Nasdaq became our major investor. And also all the customers that have trusted us and made this commercial end-to-end verification, verified carbon removals, trade and change hands have been major steps. We have, like I said, global reach, USA being the biggest buyer country. And on the supply side, we have then Finland and then followed by USA, Sweden, Canada. But not only these countries, these are the major and biggest countries. We've seen nice volume growth and nice price growth since we started, but of course, we want to see much, much more of that in the future. One cork is CO2 removal certificate of net removal, meaning that we'll very much look at the stored carbon. So start with the storage focus and deduct emissions from that. That's the basic mathematics, carbon mathematics for all carbon removals of any type. Removals include capture, stabilization, and storage in very different forms. And we've seen that when we are a technology neutral, storage focused standard, and then the marketplace once the carbon removal credits are issued. And we work on all of these different pathways to either remove carbon from the atmosphere through different pathways on land, in ocean, into durable products or geological storages, and then cutting the return pathways. The red ones are the ones where we already have a standard ready and verified carbon removals, biochar, bioenergy with carbon capture and storage, or direct air capture and storage, durables made of biomass, or then carbonated materials. And then the other ones are being worked on. For example, enhanced weathering is in this space of mineralization. So the carbonates, enhanced weathering, and to some extent CCS has a mineralization component in it. There is an audit process for every project, site specific. And the first step is looking at the site eligibility, structural checks, and life cycle assessment. And then if there are no changes, structural or big concept changes, then you can do a 5-year annual report, and then you enter again this every 5th year site audit. And the annual checks are the annual record keeping of production, CO2 source, emissions, sales, lab results, deliveries, everything that can change and be checked every year. And this is where I would like to end for you who are now developing carbon removal, mineralization, carbonation technologies. What would I advise you to keep in mind? One is that the net negativity is the key. So have it with you from the beginning as a back of an envelope calculation, and then enrich and work on it throughout the whole technology development project. Verification is another thing which you need to keep in mind. The records need to be there, and make sure that your design, your technology delivers the data very automatically, very cost efficiently, and then you are well off. The safeguards already mentioned here, environmental and social, need to be kept in mind. And I would personally consider especially water, biodiversity, and then the local community. Monitoring, anything that you can eliminate in the design phase, in the structural specifications, do that as much as you can beforehand. And then monitoring, cost-efficient monitoring for the must-have things that you can't eliminate in the design. And the final thing, this financial additionality, how important is the carbon credit revenue for your project to be profitable? The buyers would sometimes like it to be the only source of revenue, and then the investors would like to see revenues from already established markets with established prices, so that they can actually forecast, is this a reliable project to deliver and perform? So there is a bit of a dilemma there. But that was my very quick summary. So looking forward to your questions and meeting you later today.
Thank you so much, Marianne. Thanks, Colin and Phil as well. Okay, we've got a few minutes for questions. Nikki, I'll look to you to help me out with timing, but just for how we want to do this. But I'm going to say we have at least 15 minutes for questions before we go into breakouts. Let's please use I see a couple people doing this, use the raise hand function. So at the bottom of your Zoom, go to the reactions, smiley face with a plus little hat on her head. And there's a raise hand function in there. We'll see your hand, we'll call on you, and you go go away. So let's go to Chris Cogswell and then Luca. Chris, please go ahead. What's your question?
All right. Thanks for all the really cool presentations. I feel like every one of these that I go to, I learn a tremendous amount. So that's been really helpful. I especially appreciate the sort of market-based approach that Marianne was showing us. That's really cool. I had a question, I guess sort of a general question on the heat material balances we're supposed to present. So at what level of specificity are the judges going to be looking? We sort of have a very complex flow chart diagram that goes through all the mixings and heats and all that kind of stuff, but then we also have a more simplified version. Which version, I guess, or sort of what level of calculation are we expected to provide?
Great
Hi,
question.
everyone. Yeah, Mike from XPRIZE here. I'll take a stab at that one. So I think that's a good question. I mean, the priority is making sure that the overall system's mass and energy balance makes sense. So within each of your system, you might have a variety of different reactions or different sub-processes happening. And I think, the judges want to make sure that they have an understanding of what's going on there. And especially anything that is like unique or new or innovative would be really good to highlight. But it's absolutely critical that your overall, big system mass and energy balance is established, that you can account for all inputs and outputs, both on the mass side and on the energy side, and I should say as well as the carbon side, making sure that you're accounting for all the carbon flows in your system. Does that make sense?
Yeah, it does. Okay, and I'm assuming that we would be available. We would be answering the questions that anyone would have. We have like our flow chart now is like 80 streams long, so it's going to be a fairly complex one. So yeah, I'm assuming though that we would be answering any questions the judges have. I just want to make sure that my Excel chart is translatable to someone else's brain. You know what I mean? It's.
I mean, that's certainly the trick, and I mean the challenge for us is that there's so many different styles of processes out there. So
yeah,
I definitely appreciate what you're saying. So there's a certain amount of discretion that you've got in terms of like what level of detail. Erring on the side of more detail isn't necessarily a bad thing, but like I said, that focus on, for the mass energy balance in particular, focusing on the sort of the outer layer system boundary and all of the streams that cross that system boundary is the most critical piece.
Perfect. Okay, thanks so much.
Luca next, go ahead.
Yeah, first of all, thanks for the presentation. I actually related to the exactly same question because drawing the phase diagram, I have a question about, for example, the electricity flow rate. In that sense, it has to be calculated or it has to be integrated. I understand it is calculated for the LCA because, of course, the source of electricity make a difference. But in that sense, I don't really know how to put in the mass flow rate of the whole flow diagram. And also for the transportation system, in case we're using like ships or track for bringing the rocks to one side to the other, how actually that is counted. For example, the energy, like the fuel for the ships, for the fuel for the track, and their own actual emission. So how that actually I can put that in a mass flow rate, especially in the stream table. That is quite confusing at the moment.
Yeah, good point. So, I mean, I believe that the life cycle emissions form does ask specifically for transportation, as does, and you can implement that in the cost form fairly easily as well. The emissions associated with transportation can be taken in like ton kilometers kind of thing. On the mass and energy side, we didn't have the important thing is fundamentally communicating to the judges what's going on in the system. So and it's less about like the energy associated with running a ship, for example, is much less. It doesn't have as much to do with the reaction mechanics as like the energy that you have to put into a grinder, for example, if you're grinding up minerals. I think that there's a distinction there. I mean, I don't know if any of the experts we heard from this morning want to speak to how it's dealt with in other projects. But I think there's kind of some room for interpretation there. We want you to be as thorough as you can, but what we're trying to accomplish is make sure that the judges have solid understanding of the mechanisms that are doing the CO2 capturing and sequestration,
Okay, so as far as I understand, I just have to focus on the process itself. And then from where I take the input, for example, for transportation, where I bring the minutes and so on, I'll put it in the LCA, is what you're saying.
I think that's what I'm saying, yeah.
All right.
Yeah.
Okay, cool. All right. Thanks a lot.
Great.
Yes, that was it from my side.
I could maybe complement that. I think it's you always have to be able to summarize from top down. So there must be a simple presentation of what you're doing, and then you can go down to detail. But you must be able to summarize and simplify on the highest level.
Yeah, that's a great point. And I'll just add before we go to Patricia, you might be thinking, well, I'm going to submit a lot of detail, and if the judges are confused, they will ask me. No, that's not right. There won't be, don't expect detailed back and forth between your proposal and the judges. Imagine that just because of the volume of proposals, we won't have time for an extended back and forth period. So concentrate, as Marianne said, on including detail, but then making sure it's presented as clearly as you can. We'll keep talking about that over the next few weeks, but that's something to keep in mind. Don't assume that judges will be able to sift through and sort of pull out the relevant information, make it obvious. Okay. Patricia.
Perfect. Thanks a lot.
Thank you, Luca.
Thanks, Marcus and all. My question is regarding registration, actually. So we have 2 company affiliations on our projects. And my question is, are these considered team entities, both? So hence, no one else but the team lead needs to sign the Exhibit G, which is regarding the team member release. Sorry, you're muted.
Yeah, sorry, I muted. I think the answer is yes. So even if you have other partner affiliations with your team, whoever you designate as a team lead is all we really need to know about for the purpose of the agreement. Does that answer your question?
Yes, thank you.
Great, thanks. Hennady, please, go ahead.
Hi guys. So it was mentioned that storing in that there are some issues with mineral rights, let's say, with using. Basically, long story short, the question is: are there any problems potentially with storing like solid material in abandoned mines, mines shaft? So it's a question to an expert in this area.
So maybe I'll take that since I raised the comment. So you would have to probably demonstrate that there's a pathway to regulatory approval for that, since presumably there would need to be some regulatory approval to inject new material into those mines. Demonstrating that as feasible within some set of jurisdictions would probably be sufficient, but the specific requirements will be up to the rules from XPRIZE.
And I suppose just add to what Colin said is, I suppose you need to demonstrate that it would, or at least reason that it would be scalable, so that there'll be enough, space to store, a gigaton per year of CO2 over, a meaningful time period, sort of as the next century or so. So, and in terms of sort of geochemistry, though, there's, if your mines are oxidized, then you potentially have acid mine drainage, which won't really be a good place to put a carbonate. But that's only, I suppose, if oxygen is getting into the mine.
If I can just speak from the competition perspective, like the rules perspective, whatever you do during the competition needs to be legal. you have to make sure that whatever you're doing, like between now and 2024, is legal, and that you know you can get the permits, for example. However, we do understand that it may not yet be legal to do gigaton scale. We're not asking you to do gigaton scale, and so you'll be asked to articulate in the scalability section of the application. You know, you can speak to that uncertainty, but it's not like a just because it's not legal today doesn't mean that it's out. Does that make sense?
Yeah, I think just to clarify, Mike, you're saying just because the things you may need to do to get to gigaton are not legal today, it's not out. But anything you do physically that you demonstrate should be legal. In case there's any doubt, we're not liable. But you don't want to be either. So, and we're not trying to encourage that.
May I complement a little? Thinking of the jurisdictions here, countries have very different legal framework. I would advise you to see if there is a difference between your home country and the country where you are going to do your project. If the receiving country doesn't have a jurisdiction and your home country does, it may be wise to follow your home country's requirements.
Yes, great advice. Let's go to Nicolas, please. Go ahead.
Yes, hello. I've got a question about the LCA. In my LCA, I've got carbon capture, storage, carbon emission, and carbon avoided. And I didn't know if I can't count at all the carbon avoided, or if I can subtract from my emissions the carbon that I avoid, because I replace something today that generates a huge amount of carbon. So how should I calculate it?
For the purposes of the LCA and the competition, we are not including avoided carbon. We're only interested in removals. So the only things that we want you to indicate on the LCA are emission sources and carbon sinks. However, you can talk about the avoided emissions and potentially the products you produce or whatever the co-benefits are in the sustainability section of the application. So that's you can talk about that with the judges, but numerically, as far as the LCA is concerned, we're only interested in removals.
Okay, thank you.
A complement to that again, we also in Puro don't calculate or quantify into a cork these avoided emissions. You can have them there as more or less marketing material and self-declared. So some buyers do want to see also that part. I would advise you to separate fossil emissions, biogenic emissions, and land use emissions, so that if there is somebody who needs to see them separately, that is also available.
Great, thank you. Thanks for the question, Nicola. Kunal, please go ahead.
Thank you for having us here. So my question, so let me introduce myself. So I represent this group of scientists and engineers who are working out of Canada and USA. We're working on a project called Solid Carbon. It's an offshore direct air capture and carbon sequestration technology. So the main idea is that we'll be able to capture we'll be able to do direct air capture of carbon dioxide and then inject it within ocean basalt. Now, my question is to essentially all three of the panelists here. So ocean basalt sequestration is still fairly, being worked at. I mean, even the monitoring technologies needed to kind of understand how carbon dioxide essentially mineralizes are still being developed. And so essentially from perspective of verification, how does that work out? Because I did not see geological sequestration in Marianne's slide in the ocean track. And so I was just curious, what are the panelists' thought, especially on with regards to offshore basalt sequestration? Thank
you. I think you probably aren't suffering any more than any other project is really with in terms of sort of at the stage of development and challenges around MRV. So yeah, I mean, if you can demonstrate that you've got a molecule of CO2 going out of the atmosphere and going into a sort of a permanent storage reservoir, then I suppose that's, from my perspective, seems legitimate.
Yeah, I would agree with that. And I want to remind that there are very different types of buyers. Some want to support very immature technologies where the science is not yet discovered, and some want to have more mature things where they are sure of the science and no longer uncertainties exist. So you can find both types of buyers.
Nothing much to add. Yeah.
Great. Thank you, Kunal. Thomas, just a time check. I think we'll go for another 5-10 minutes of questions, so keep them coming. And then I'll turn it over to my colleagues to direct us into our breakouts.
Okay, I'll try and be quick on mine then. What I'd like to know is, what should we expect the judges to know about demonstrated and published technologies? And let me give you a couple of examples. Amine scrubbing for removing carbon dioxide, oxyfuel combustion, in situ mineral carbonation. Do we have to explain the technology and then the particular aspects we're doing? Or are we better off concentrating on our particular approaches to things? It's not clear to me that a judge is going to know what these are. We don't want somebody to look at it and say, hey, I don't know what this is. But at the same time, we don't want to spend a lot of time explaining something like amine scrubbing when it might be a particular amine that's important. So where do we cut the line?
I'll just start, and I'll invite any of my colleagues to build on what I say here. Our judges know what they're doing. They know what they're talking about. They know the basics. We have a panel with a very broad range of experience, and so all specifically the technologies that you mentioned are all technologies that I know we have expertise on in the judging panel.
So I can write it like I'm writing a paper as opposed to like I'm doing an explanation to a high school class.
So I think it's important to start with just a very brief explanation with all the steps so that everybody knows what the terms of reference are, and then very quickly shift into the areas of novelty, or where the area where you're really adding value. That's my recommendation. I mean, Marcus, Phil, what would you say?
You're in good hands, Thomas. I'm not going to. I'll say that you're right. The only thing I would quibble with that Mike said was the basics. The judges, they know the basics and they know everything. Together, they know everything. I'm only half joking when I say that. I think we have a significant fraction of some of the deepest thinkers on Earth in our network of judges, people like Marianne and Colin. We have a whole group of people that are also going to be skimming through the proposals to sort and filter them before the main judges like Phil get their hands on them. And so we're doing this collectively so that you can write freely, Thomas, about your stuff. You don't have to explain amine scrubbing to anybody. Assume amine scrubbing, check, just keep moving straight on and just to focus on what you are doing, either with amines or what's new that you are doing. And I said there won't be time for Q&A. If you do include something that no one understands, we'll definitely get in touch with you. If this is like, wow, this is novel, we don't get it. The thing you can't count on is, this sentence isn't complete, or this is an ill-formed thought and we can't read the diagram. That's the kind of thing you need to watch out for. I hope that helps.
Thank you.
I would like to challenge you, Thomas, to explain it also to your mother. There is a marketing, it has to be simple to be selling. And so take a challenge in writing it in 3 lines that anybody could understand.
But that's very difficult to do with the thermodynamics that are taking place internal in our systems. I am assuming that someone with an engineering level understanding of thermodynamics and heat and mass transfer will be reviewing this. Am I wrong about that?
You're not wrong. The bios of the judges are public. Be careful. I'm going to go to ELAS in a minute, but be careful what you wish for. You may get more scrutiny and depth on the thermodynamics process than you're.
I love that. That's good.
Yeah. Yeah, we're ready for you. I'm smiling because I know which judges are going to go deep on it. So, but you're in great hands. Great question. Elias, go ahead, please.
Yes, hello everyone. Just to clarify, because I'm a little bit confused on the scope, we are talking about the carbon dioxide removal from air and ocean, but flue gases are in the air. And I was told that removal from point sources is out of scope altogether. Colin also brought up some comment related to that. So is that accurate, or is it out of scope? Say, for instance, that we are removing CO2 from that is emitted from biogenic sources, like a combustion of biologically based materials. Is it out of scope?
Biogenic sources are in scope, and fossil sources are out of scope.
Okay, so just point sources that are using fossil fuels that are out of scope, not
Correct.
Point sources or ethanol plants that are using corn or sugar. Those are in scope.
Correct. Now, the only caveat is that we do expect you to speak to the full supply chain upstream of the plant that's providing the flue gas. So we need you to account for costs, carbon, and sustainability of the biogenic feedstocks.
Gotcha. Thank you, Mike.
Carbono, go ahead, please.
Hi, everyone. I would like to know about, or going deep in the, what are you looking in when you talk about best project and performance in this phase or milestone road? How specific do we have to be in all this project explanation? So what are you looking? You talked, Michael, yesterday about performance. What are you looking when you said performance in this milestone road?
So at this phase in the competition, we have operational requirements, and there's three parts to the operational requirements. We're looking for a proposal for the CDR system, the carbon dioxide removal system that you're going to be building over the next couple of years in competition for the grand prize. The second thing we're looking for is a demonstration, and that demonstration can be it's up to you to define the scope and the scale of the demonstration. We don't have any requirements, but we want to see that demonstration show the performance of some aspect of your system. We call it the key component of your system. It's the performance of that demonstration that we're interested in at this point in time. And it's the verification requirements. That's the third piece of the puzzle at this round. The verification needs to be of that demonstrated component. So when we talk about performance, we're talking about what are you demonstrating today? How is it supposed to work? And how does it work in real life? Does that make sense?
Yeah, but I'm quite worried about explanation, the documents that you are looking for, that how the detail must to be in order to support our system. I could be really secure about what we have, but I'm kind of a little worried about all the documents that must show the performance, not in the physical way, but in a maybe abstract or in quantities and documents and measurements that you could understand perfectly how a process works in order to be measured. That's my main worry. I don't know if I'm explaining or
yeah. Yeah, I understand. So we provided some templates with some checklists where we try to describe that. You know, at a very broad level, you know, it's a good idea to include some drawings so that the judges understand, you know, what you're talking about. We ask you to define the performance metrics that characterize your demonstration. So, you know, basically write out in words, you know, what exactly, how do you define performance? And then we want to know the source of the data that proves the performance. So, you know, what instruments are you using? What kind of data is being collected? And then how does it boil up into essentially works as intended check, or, you know, still work to be done. So we definitely want to see that full chain, like basically all the way starting from the instrument all the way up. You don't have to provide us with every data set that you've ever collected, but we want to understand how it works, and we want to see evidence that you've operated your system and that you have a good understanding of how it works.
Okay.
Okay, we are going to see if we can do two more very quickly before we go to breakouts. Peggy and then Maurice. So Peggy, go ahead, please.
Yeah, my question is for Marianne. In the very last slide that she showed, she talked about buyers of carbon and that they would like no other source of revenue. And my question with that is, like if we want to protect a national forest or a natural ecosystem, what we use to protect it is extractive reserves, mushrooms or medicinal herbs, or anyway, those become sources of revenue. And was she saying that buyers don't want that type of complexity? That's my question.
Yeah, and now I can't put all buyers in the same box, Peggy, but there is this concept of financial additionality, that the sponsor wants that their money is the only reason why that activity exists. It's a legacy from the emission reduction era, which does not fully translate to carbon removal era. And I think that there is maybe that will be thought of, but at the moment some buyers find that very important. Some don't think in that way. Some think that it's good if there are several sources of revenue and many byproducts. So don't take it as a given. You'll find other types of buyers.
Okay, thank you very much. And last question to Maurice. Try to keep it brief if possible. Go ahead.
Yeah, thanks very much. Thank you all. Two quick questions. So verification, can it be an academic kind of peer review? And if so, kind of what level of depth is needed? Because I only have a month to do it, so I'm a bit worried about that. And the second thing is, in the application we do, is it made public, or can we kind of disclose figures and results that maybe we wouldn't want to disclose publicly? That's it. Thanks.
I'll answer in reverse order. So the applications are not made public. Everything is protected by NDA and kept strictly confidential. There is one section where we ask you for like a public-facing description. We've made it fairly clear, you know, which section that is in the application. So just keep that in mind. But anything that you upload, any drawings, any schematics, will be kept confidential. Everybody who has access to that information is under NDA. Your first question was about verification. So typically, like, peer review is typically not considered robust enough, but if you're asking, can it be reviewed by a peer? The answer is yes. We've provided a checklist that has all of the items that the verifier needs to include in the verification. And our only requirement is that the verifier is qualified, that is, has expertise. And so, you know, a esteemed colleague should qualify. And that they are independent. So they should not be involved in the project or in the development of the equipment or the technologies related to the project. So, so beyond that, you know, just to say, here's a published paper and it's undergone peer review is not sufficient. But to have an academic colleague conduct the review and, you know, write a report that meets our requirements is totally acceptable.
Okay, great. Thank you for the questions. We're going to end that portion. Thank you again, Phil, Colin, Marianne. We really appreciate your time. Thanks for staying late, Marianne and Phil. And thanks for staying medium, Colin. We really appreciate you.